One of the most enduring questions in astrobiology is there anyone out there? And by anyone, that means extraterrestrial intelligence. Could we find another intelligent civilization in the galaxy or in the universe at large? Well, one of the first people to really think about this and apply these ideas was Frank Drake, an American astronomer and astrophysicist, a pioneer in the search for extraterrestrial intelligence. And in 1961, he wrote down an equation that's become rather famous and has now become known as the Drake equation to try and estimate the number of communicative civilizations that there might be in the universe. Of course, one of the first things we have to do is to define what a civilization is, and there are a number of ways that we might do that. We might define a civilization as a group of organisms that have built certain technology. Maybe they've built cities or something else. But of course, if we're going to detect an intelligent civilization, they need to be transmitting signals to us. So from an operative point of view, we might simply define an intelligent civilization as a civilization that is able to communicate with us, for example, using radio waves. So the Drake equation is about trying to estimate the number of communicative civilizations. What are the terms of this equation? So this is the Drake equation, and it's made up of a number of factors. And we have to estimate values for those factors to be able to put them together to estimate the total number of communicative civilizations in our galaxy or perhaps in the universe. The first term, R, is the rate of formation of suitable stars for life. Well, we know that G stars are suitable for life because our own star is a G-type star. But there might be other stars that are also suitable for planets with intelligent life, for example, M stars. And at the moment, we don't really know enough about the types of stars that can give rise to intelligences on a planet. But we need to work out the rate of formation of suitable stars to be able to put that term into the equation. So that's clearly one forthcoming challenge for astrobiologists. The next term is the fraction of these stars with planets. A few decades ago, this was pure speculation. We just didn't know of planets around other stars. Now, with an increasing quantity of data about planets orbiting distant stars, we can begin to get a more accurate estimate of the number of stars that actually host planets. And so we can begin to put some estimate on this term in the equation, Fp. Once we know that, we then have to know the number of Earth-like worlds per planetary system. And again, at the moment, we don't know exactly what this number is, but as we increase the search for Earth-like planets, and by that I mean rocky terrestrial-type planets that could host liquid water and even biology, then we can start to put that number into the equation. The search for extrasolar planets around other stars, and particularly the recent search for Earth-like planets around other stars, is bringing us closer to a time where we can actually estimate a number that could go into the Drake equation. Once we have that number, we then need to work out the fraction of these planets where life develops. We just don't know enough about the origin of life, what conditions are required for the origin of life to be able to work out the fraction of planets that are habitable, that do actually give rise to life. And this again is a challenge for astrobiologists to work out what really were the conditions for the origin of life. How likely or inevitable is it that these conditions will be met on other planets that are habitable? And so what fraction of planets will inevitably give rise to life? That's another term that we don't have an accurate number for, but we would need in order to be able to work out the solution to this Drake equation. Once we know the number or the fraction of planets where there's life, we then need to be able to work out the fraction of those planets where intelligent life evolves and develops. And again, at the moment, that's entirely speculation. We don't even know whether there are other planets in our galaxy or in the universe that have life, let alone whether they have intelligent life. But if we were to be able to work that out, if we were to be able to look at enough Earth-like planets around other stars, assess them for their potential for life, and assess whether they could support intelligent life, we could then move on to the next term in the Drake equation, which is the fraction of those planets that are communicating. And the only way that we can really work that out is to try and pick up signals from other planets where there are intelligent civilizations that are communicating. And then finally, the last term in this equation is the lifetime of communicating civilizations. This is a term that constrains the total number of civilizations that are attempting to communicate by taking into account the fact that these civilizations might have finite lifetimes. Civilizations might destroy themselves. For other biological or technological reasons, they may come to an end after a certain length of time. We would need to take that into account to work out the total number of communicative civilizations. So this Drake equation contains some terms that we can be more accurate about. For example, the fraction of stars that have planets. Some terms we really don't know anything about at the current time, such as the number of habitable worlds that give rise to intelligent life. But the Drake equation is a very interesting way of thinking about astrobiology. It's a very interesting way of ordering our thoughts. And ultimately, it's the equation that we will need to be able to estimate a value for in order to be able to know whether the search for extraterrestrial intelligence is an initiative that's worth undertaking. When Frank Drake first came up with this equation, he estimated that there are 10,000 communicative civilizations in our galaxy, based on the numbers that were known then. Of course, trying to come up with more accurate numbers is a very difficult thing to do, but astrobiologists need to use the Drake equation to try and formulate a more accurate assessment of the number of communicative civilizations in the galaxy. Given the number of planets that have been observed around other stars, and the number of Earth-like planets that are beginning to be detected around other stars, we might expect that this number will change, possibly even upwards, over the coming decades. Although, again, we still don't know, even if there are many Earth-like planets in the galaxy, how many of those might support intelligence. So what have we learned? Well, we've learned, of course, that we don't know whether there is anyone out there. But by coming up with this equation, the Drake equation, we have some sort of method of trying to quantify or estimate the numbers of communicative civilizations in the galaxy. The equation depends upon many factors that depend upon the formation of planets around stars, the formation of habitable conditions on those planets, and the emergence of life and eventually intelligent life. When Frank Drake first attempted to come up with a value that results from this equation, he estimated 10,000 communicative civilizations in the galaxy. This equation is a very good way of underpinning our search for extraterrestrial intelligence and trying to find out where the search for extraterrestrial intelligence fits in with astrobiology.